Okay. So the biggest difference here is that instead of having half reactions, you're going to be given a total reaction, but you still balance it as two half reactions. So for example, in this one, you would look at the U4 plus going to the UO2 2 plus, and then the other half reaction would be MnO4 minus going to the Mn2 plus. So same process though. We are going to major hydroxide. First off, balance your majors. Then you're going to balance your oxygens, balance your hydrogens, balance your charge, and then here's your new step. Our new step is that we are going to balance the electrons in the two half reactions so that we can put them back together. So redox reactions only happen because one reaction gives up electrons and the other one receives the electrons, right? One is oxidized and one is reduced, but they have to give and receive the same amount of electrons. So in this example, I am oxidized and giving off 2 electrons, and then this half reaction is being reduced and accepting or gaining 5 electrons. So to make this into a common number, we're going to give and take 10 electrons. So this reaction I'm going to multiply by 5. So you'd end up with 5 U4 pluses, 10 waters, goes to 5 UO2 2 pluses, and 20 hydrogens. That's not 2 hydroxide plus, it's 20 hydrogens, and then 10 electrons. And then the other reaction we'd multiply by 2. So you have 2 MnO4, 16 hydrogens, 10 electrons, 2 Mn2 plus, and 8 waters. And then the whole point of this is that when you put them together, the electrons are going to cancel out, right? So I often don't write this intermediary line. I often cancel them out above, but some people like this. So my electrons are going to cancel out. My waters are going to balance. So instead of having 10 on the left-hand side, the 8 on the right is going to make this a 2. And then the hydrogen ions, I have 16 on the left and 20 on the right. So now I'm going to have 4 on the right. So then my overall reaction is 5 U4 plus, 2 waters, 2 MnO4 minus, goes to 5 UO2 2 plus, 4 hydrogen ions, and 2 Mn2 pluses. And then you can double check your majors, double check your charge, but bare minimum double check your charge. So this would be plus 20 and then minus 2, so that's 18. And then on this one you have 10 plus 4 is 14, plus another 4 is also 18. Awesome. Then if the question asked you to adjust for a basic, you would. Now the one that I gave an example just said balance acidic, so I'm going to stop there, but there will be some that we have to balance in basic. Now if anybody finds that really confusing, there is an alternative method. I will say it's not necessarily less work, it's maybe a little bit more mental work. The reason I like this method and I teach this method is that it's just flowing from what we just did. But if this method is like, heck no, I won't go, you can read Hebden and you can do the practice questions on page 210, number 25. I might make some optional videos to watch method 2, but really what I recommend is just reading the textbook for now. And if enough of you ask me, I will make an alternative video. But I will say it's not any easier. Okay, so next reaction. So let's break it up first off into 2 half reactions. You're going to have, now I've changed the way I used to do this. I used to try to write 2 half reactions, one on each side of the page, and now I do them on top of each other, and I find that it has actually made my life a little bit easier for some reason. So we're going to put Mn2 plus goes to MnO4 minus. Let's just balance this one first. So balance your majors, done. Balance your oxygens. Now it's done, right? So add 4 waters. Then I'm going to balance my hydrogens. So I need 8 hydrogens on the right. And then lastly, I'm going to balance for charge. I have plus 2 charge on the left, and I have plus 7 charge on the right. So I'm going to add 5 electrons on the right. For the next one, I've got HBiO3 going to Bi3 plus. And again, balance your majors, done. Balance your oxygens. There's 3 oxygens on the left, so I'm going to add 3 waters on the right. Balance your hydrogens. I have 6 on the right and 1 on the left, so I'm going to add 5 hydrogens on the right. And then I'm going to balance for charge. I have a total ionic charge on the left of +5. I have a total ionic charge on the right of +3. So I'm going to add 2 electrons on this side. Then the last step, because this is acidic, is that this guy is giving or receiving, gaining 2 electrons, and this one is gaining 5. And you need to gain the same amount. So gain and lose the same amount. So this one I'm going to multiply by 2, and this reaction I'm going to multiply by 5. So I'm going to go like this, and I'm going to say that now I have, now it's kind of personal preference. Some people will write it in one big long line now. That's too much for me. So I'm going to multiply this top one by 2. So I have 8 waters and 2 Mn2 pluses goes to 2 MnO4 minus and 16 hydrogens and 10 electrons. Then on the bottom, I'm multiplying everything by 5. So I have 10 electrons. I have 25 hydrogens. I have 5 HBiO3. I have 5 Bi3 plus, and I have 15 waters. Fun, hey? Then I'm going to write, now I go straight to my final answer, and I'm going to cancel out the things that I can. So 10 electrons, 10 electrons. I have 25 hydrogens on the left and 16 hydrogens on the right. So I'm going to get rid of all the hydrogens on the right, and then I have 9 on the left. And then for the waters, I have 8 waters on the left and 15 on the right. So I'm going to go 15 minus 8 is 7, and I'm going to be left with 7 waters on the right. And then I write my overall reaction. So on the top, all I have left is the 2 Mn2 pluses. On the bottom, I have 9 hydrogens, and I have 5 HBiO3. And then on the right, I am going to have 2 MnO4 minus and 5 Bi3 plus and 7 waters. Fun times. All right, let's try the next one. All right, so let's do one more in an acidic situation. So we've got Cr2O7 2 minus going to Cr3 plus. Now, if you're anything like me, the number one thing you're going to forget is to balance your majors, and it's the most important part. The number of these I had to redo because I forgot the majors. Don't be me. So I have 2 Crs on the left, and I want 2 Crs on the right. Now I'm going to balance my oxygens. I have 7 on the left, so I'm going to add 7 waters on the right. Now I'm going to balance my hydrogens. I have 14 hydrogens on the right, so I'm going to add 14 hydrogens on the left. Then I'm going to balance for charge. 14 minus 2 is 12. 6 on the right, which means I have to add 6 electrons on the left. For the next one, I have I minus going to I2. Again, I have to balance for majors, but there's no oxygens, no hydrogens. Yay! So now I get to balance for charge. I have -2 on the left, I have 0 on the right, so I'm going to add 2 electrons on the right. Then I want to make sure that my electrons are balanced. So this one needs to be reduced with 6 electrons, so this one is only oxidizing and giving off 2. So I'm just going to take this bottom reaction and multiply it by 3. They're not all the worst. So now I have 6 electrons on the left, 14 hydrogens, and the 2 dichromates, forming 2 chromate ions and 7 waters. And then this bottom reaction, I'm going to multiply everything by 3, so I have 6 iodine ions, and going to iodine, 3 of them, and then I have 6 electrons. Now the nice thing about this one as well is that only the electrons are going to cancel out. So then I'm going to be left with everything else that's written. So I'm going to have, and it doesn't matter the order again, as long as everything on the left is on the left and everything on the right is on the right, it doesn't matter if you do it in a different order than me. I generally do my top and then my bottom. Oh, I'm getting a hand cramp. And then again, you can make sure that your majors are all balanced. You can make sure that your charges are all balanced. So let's just do a bare minimum of charges. I have 14 minus 2 is 12, minus 6 is 6. And on the right-hand side, I have 6. Yay! Okay, next page. Next page, we're going to do one that's basic, and then we're going to do one that's just a little bit different, but also basic. So for this one, I've given us the whole page, but the first process is just to balance two half reactions. So we're going to do this the same as we did the acidic. So we've got MnO4 minus going to MnO2. Balance my majors, done. Balance my oxygens. I'm going to add 4 waters on the right, and then I'm going to add 4 hydrogens on the left. Then I'm going to balance for charge. I have 4 minus 1 is 3. On the right-hand side, I have 0. So I'm going to add 3 electrons on the left. Then I'm going to work on my C2O4 2 minus going to CO2. I'm going to start off by balancing my majors. So I have 2 C's on the left, so I'm going to add a 2 on the right. And then I'm going to balance my oxygens. I have 4 oxygens on the left, and I have 4 oxygens on the right. Another gift. So I don't have to worry about oxygens, and I don't have to worry about hydrogens. So now I'm going to balance for charge. I have minus 2 on the right. I have 0 on the left. I have 0 on the right. I think I'm messing up my lefts and rights. And I'm going to give off 2 electrons. So now I have to balance for charge, or balance for electrons, I mean. So I'm going to take this reaction and I'm going to multiply it by 2. And I'm going to take this reaction and I'm going to multiply it by 3. So that's going to give me 6 electrons and 8 hydrogens and 2 MnO4 minus goes to 2 MnO2s and 4 waters. And then my second reaction, I'm going to multiply by 3. So I have 3 C2O4 2 minus, and I have 6 CO2s to oxidize and release 6 electrons. Okay. Then I'm going to cancel out what I can. So I've got the 6 electrons and the 6 electrons. Because my second reaction didn't involve any oxygens or hydrogens, I'm just going to be left with what's left. So 8 hydrogens and 2 MnO4 minus and 3 C2O4 2 minus is going to give 2 MnO2s, 4 waters, and 6 CO2s. Okay, don't forget, this was basic. So I've done everything. I've simplified it for an acidic solution, and then I just have to make it basic. So since I have 8 hydrogens on the left, I'm going to put 8 hydrogens on the right with the 8 hydroxides, and that's going to come from 8 waters. Then I need to look to see what's going to cancel out. So the 8 hydrogens is going to take out the 8 hydrogens, and then I've got 8 waters on the left and 4 waters on the right, so I'm going to put just a 4 here. And then I'm going to rewrite the total equation. So I'm going to have 2 MnO4 minus 3 C2O4 2 minus and 4 waters is going to form 2 MnO2, 6 carbon dioxides, and 8 hydroxides. Whew. All right. Last one. So the last one that we're going to do is going to be a self-oxidation reduction, or what we call a disproportionation reaction, in which the same species is going to be oxidized and reduced. So what you're going to notice is that this only has one reactant, okay, or there's going to be only one product. And all you do is you still have to do all the same work, but you do this Br2 goes to Br minus, and then again you do the Br2 goes to BrO3 minus, and you just have to include it twice. So feel free to pause the video and give this one a go, or just keep watching. So this first reaction I'm going to balance for majors, put my 2 there. Then I'm going to balance for charge, so this is 0, this is minus 2, because I'm going to add 2 electrons on the left-hand side. And then for my bottom reaction, I'm going to balance my majors. So I'm going to put a 2 here. Then I have to balance my oxygens. I now have 6 oxygens, so I'm going to add 6 waters. I have 12 hydrogens, so I'm going to add 12 hydrogens. Then I'm going to balance for charge. So I have 0 on the left, and on the right I have minus 2 plus 12 is plus 10. So I have to add 10 electrons. Now, the nice thing about that is that 2 goes into 10. So to balance the 2 electrons with the 10 electrons, I'm going to multiply the top equation by 5. That is going to give me 10 electrons plus 5 Br2s is going to give off 10 Br minus. And then I'm going to rewrite my whole second equation. So I'm going to end up with the 6 waters and the Br2 goes to 2 BrO3 minus and the 12 hydrogens and the 10 electrons. Then I'm going to combine those two. Now some people do balance both of them for basic and then go, I just don't want to do it twice, so I do it at the end. So then I'm going to go and I'm going to balance these or cancel out. I've got 10 electrons with 10 electrons. Everything else is good. So I'm going to rewrite this as 5 Br2. Ooh, actually, no, I'm not. I'm going to write this as 6 Br2s, right? I have 5 and 1, and 6 waters is going to form 10 Br minus plus 2 BrO3 minus plus 12 hydrogens. Okay. Then I'm going to balance this in a basic situation. Now, if anybody notices that these all divide by 2, I do have to do it. I'm just going to do it at the end to keep it simple. So I have 12 hydrogens getting released. So I'm going to put 12 hydrogens on the left and then 12 hydroxides on the left to form 12 water molecules. Then I'm going to double check if anything gets simplified. I've got 6 waters on the right, so that's going to make just 6 waters on the left, and then the hydrogens are going to go away. So my overall basic reaction is 6 Br2 plus 12 hydroxides goes to 10 Br minus and 2 BrO3 and 6 waters. And then, like I was saying, because these can all divide by 2, I'm going to do it. So my last step is to make sure that my reaction is simplified. So my last part will be that I actually have 3 Br2s, and I have 6 hydroxides, and I have 5 bromide ions. I have 1 BrO3 minus, and I have 3 waters. Having fun yet? Good luck.